This is a question from theory of computation. Consider the following DFA. Let denote the set of 8-bit strings whose second, third, sixth and seventh bits are 1. The number of strings in that are accepted by this M, this is M, is equal to. So let's draw the automata once more. Start state here, it's 1. And upon saying 0, it moves here from 1, then 0. Upon here, upon saying 1, it goes back. And upon saying 0, it comes like this. On 1, then it reaches the final state, then 0, 1. So there are two cases here in which we can have second, third, sixth and seventh bit as ones. So let's try case 1. In case 1, to get second and third bit as 1, in the first 3 transitions, it should be staying in this state only. Here 1, 2 and 3. All the 3 inputs should be 1. Then only it will be staying here. That is, upon input should be 1, 1, 1. So this is the case. Now we have an option to transit and move and reach the 6th bit as 1. To do that, the 4th transition has to be this and the 5th transition has to be this. Now to get 6th bit as 1, it has to perform this transition. Then again, to get the 7th bit as 1, it has to perform this transition only. So 7 also here. Now the last string bit is 8. 8, it can be reached from here only, or it can go back to here. But based on this condition, we cannot reach the final state with 8 bits. So this is violated. Now let's see case number 2. Let's draw the automata once again. We have 1, then we have 0, then next state, then we have 0, 1, 1, 0. This is also 0, 1, 0, 1. Let's see the case number 2. So in case 2, we can make the transitions like this. Let the first transition be this only. Now to get the second bit as 1, what can happen is this would be the first transition. Like from here we are going to 0. Then to get the second bit as 1, this transition has to happen. To even get the third bit, we can make the transition this. That is, from here we can go. And now to get the 6th bit as 1, what should happen is again we should come here, come from here to here. Then the 5th transition has to be this, and the 6th transition has to be this transition. Now to get 7th bit as 1, it has to reach here, and the 8th bit as it can be anything. So based on this transition or these cases, we can get into the final state. Now the possible strings that can be accepted by the machine based on this case is, first one has to be 0. This is the initial transition. Now second transition has to be 1 because the second bit has to be 1. Now third transition also has to be 1. Again here fourth transition also has to be 1. Now fifth transition has to be 0. Sixth transition has to be this 1. Now seventh transition also has to be 1. And eighth transition can be either 0 or 1. Let's assume it is 1. Now let's consider the second case. Here also we are forced to make this transition. So 0 here. So for having second and third bit as 1, we have to perform this transition from this to this and from this to this. So it will be 1, 1. Second and third bit are 1s. Now we are reaching here. Now we have only one option to move. So we are making that transition and we are reaching 0. From here, the 6th transition has to be fixed because then only we can make it 1. So this is also fixed. Upon reaching this state, we have to make 7th bit as 1. So we make the transition 1. Here the last state can be 0 or 1. So we are making it as 0. So based on this condition, only these two strings are getting satisfied. So the number of strings that are accepted by the machine M is 2. Option C, 2 is the right choice.